Have you ever wondered why ocean water tastes salty, even though rainwater and river water taste completely fresh? This simple question actually hides a very long scientific story about our planet. If you taste just a tiny drop of seawater, you immediately notice the difference. Unlike drinking water, ocean water contains large amounts of dissolved minerals. Water from rivers, lakes, and rain usually tastes fresh because it contains very little salt. But seawater is different because it holds many dissolved minerals collected over time. So where does all of this salt actually come from? To understand the answer, we need to follow the journey of water across Earth. These particles are minerals that dissolve naturally from rocks over time. Even though they are extremely small, they play a very important role in ocean chemistry. Rivers then carry these dissolved minerals across long distances toward the ocean. Little by little, these materials are delivered into seawater every single day. This process has been happening continuously for millions of years across Earth's history. As a result, minerals slowly built up inside the ocean over an incredibly long time. Two of the most common minerals carried into the ocean are sodium and chloride. When these elements combine together, they form the salt that makes seawater taste salty. As more and more salt entered the ocean over time, seawater slowly became saltier. This gradual process explains one of the main reasons why ocean water tastes the way it does today. But this is only part of the story behind the ocean's saltiness. Another powerful natural process is still working today to keep the ocean salty. But here is something interesting to think about. If rivers are constantly bringing minerals into the ocean, why doesn't seawater become less salty or turn fresh again over time? The answer begins with energy from the sun. Every day, sunlight heats the surface of the ocean and slowly changes part of the seawater into invisible water vapor. This process is called evaporation, and it allows water to rise into the atmosphere. However, only pure water evaporates, while the salt stays behind in the ocean. This means that each time evaporation happens, seawater loses water but keeps its salt. Over long periods of time, this process helps maintain the ocean's salty composition. As water vapor rises higher into the atmosphere, it begins cooling and forming clouds. These clouds are made from tiny droplets of fresh water, not salt water. Winds then carry these clouds across continents and over mountains. Eventually, the water inside the clouds returns to Earth again as rainfall.
Because the salt stayed behind in the ocean during evaporation, the rain that falls from clouds remains fresh. This is why rivers and lakes usually contain very little salt.
This repeating movement of water between the ocean, the atmosphere, and the land is called the water cycle. It is one of the most important natural systems on our planet. For millions of years, evaporation removed water from the ocean but left the salt behind. At the same time, rivers continued bringing new minerals into the sea. But surprisingly, the ocean did not become endlessly saltier over time. Instead, the level of salt in seawater reached a natural balance that still exists today. So what keeps this balance stable across millions of years? If salt is always entering the ocean, something else must also be removing it. To understand this hidden process, we need to travel deep beneath the ocean's surface. There, powerful geological forces are still shaping the chemistry of seawater today. To discover another source of ocean salt, we need to explore what happens deep below the surface. Far beneath the waves, the ocean floor is still active and constantly changing. The deep ocean floor is not flat or quiet as many people imagine. Instead, it is filled with underwater mountains, cracks, and moving tectonic structures. Some of these structures are underwater volcanoes that release heat and minerals from deep inside Earth. These hidden volcanic systems play an important role in shaping ocean chemistry. In many places along the ocean floor, special openings called hydrothermal vents release extremely hot water. This water carries large amounts of dissolved minerals from deep underground. As this hot water rises into the ocean, it mixes with the surrounding seawater. During this process, important minerals are added directly into the ocean environment. Among these minerals are sodium and chloride, the same elements that form common salt. This means the ocean floor itself is continuously supplying salt into seawater.
Unlike rivers that bring minerals from land, these deep-sea vents work continuously beneath the ocean. They slowly release new minerals into seawater every day across the planet.
Once these minerals enter the ocean, powerful ocean currents begin moving them around the world. This circulation helps distribute salt evenly across the global ocean system. Even though salt is constantly entering the ocean, the total amount does not increase forever. That is because another natural process is quietly removing salt at the same time. Some salt slowly settles onto the ocean floor and becomes trapped inside marine sediments. Over long periods of time, these sediments can even turn into solid mineral rocks. But here is another interesting question scientists often ask about seawater. Do all oceans around the world contain the same amount of salt everywhere? Although all oceans are connected across our planet, their salt levels are not exactly the same everywhere. In fact, scientists have discovered that salinity can vary from region to region around the world. Scientists measure ocean salt levels using something called salinity. This measurement helps them understand how much dissolved salt exists inside different parts of seawater. On average, seawater contains about 3.5% dissolved salt. This number represents the typical salinity level found across most of the global ocean. However, some seas contain much higher salt concentrations than the global average. In these locations, the water becomes denser and allows people to float more easily. A famous example is the Dead Sea, one of the saltiest bodies of water on Earth. Its extremely high salt concentration makes floating on the surface surprisingly easy. The Dead Sea becomes so salty because water flows into it but cannot flow out again. Instead, intense evaporation removes water while leaving nearly all of the salt behind. As more water evaporates from the surface, the remaining salt becomes increasingly concentrated. Over time, this process creates some of the saltiest natural water found anywhere on Earth. On the other hand, some seas contain lower salt levels than average ocean water. These regions usually receive large amounts of fresh water from rivers or frequent rainfall. So the salinity of seawater depends mainly on three important natural factors. These include evaporation, rainfall, and the amount of fresh water entering from rivers. Ocean currents also play a major role in moving salt across different regions of the planet. These powerful currents help maintain balance within the global ocean circulation system. When scientists study salinity, they see that the ocean behaves like a dynamic and connected system. Many natural processes work together continuously to maintain this delicate balance. But ocean salt does more than simply change how seawater tastes. It also plays an essential role in supporting marine life and regulating Earth's climate system.